Afternoon, problem solvers. Today we're going to work on IXL assignment UQL, multiply using the distributive property with negative numbers. So when we think about the distributive property, that word means to distribute. In this case, what we're distributing is multiplication, but we're giving it out, we're multiplying a bunch of things. So that's kind of where the word comes from. If we look at these two examples here, we can use the distributive property either when we have only numbers or when we have variables. It really mainly helps us when variables are involved, and I'll get to that in a moment, but it technically works with numbers too. And let's solve a problem that way so you can see why this works. And it's not like it's a fancy trick or something like that. It works all the time. So if we look at this problem here, 3 times the quantity of 8 plus 2, and you were asked to simplify this. Well, the normal thing that we would think to do is follow order of operations, and we deal with any grouping symbol. Well, I see here my parentheses are acting as a double agent. They represent both a group of things and they represent multiplication. So they're grouping our 8 plus 2, but they're also multiplication because that 3 is on the outside. That 3 is being multiplied by our group. So if we choose to solve this by following order of operations, we would start with adding what's inside the parentheses. So I'll do the work up here. So 8 plus 2 is 10. 3 times 10 is the answer of 30. So we've simplified. This problem equals 30. But if we chose to do our work differently and use the distributive property, that's what has been worked out here for us. Because of these parentheses being around this entire thing, it's telling us that the 3 is being multiplied by everything inside the parentheses. So we can take 3 times 8, which is pictured here, and we can take 3 times 2. Well, when we do that, 3 times 8 is 24. 3 times 2 is 6. And if we add that together, we get the answer of 30. So when you're dealing with only numbers, you can follow standard order of operation, or you can use the distributive property to simplify. Both works, and they're both valid methods because they're getting rid of those grouping symbols first. All right. Now, let's look at the problem on the right here when we have 4 times the quantity of x plus 3. Why could we not use standard order of operations here and do the x plus 3? Hopefully you're saying, well, Mrs. Ailstock, it's because they're not like terms. So when we think about typical order of operations, we go to those parentheses, we go to those grouping symbols. But when we look inside, we have a variable x plus a constant 3. When you're talking about adding and subtracting things, they have to be like terms. And these are not the same because one has a variable, one doesn't. So we can't do that. So the only way we can get rid of those parentheses is by using the distributive property, because this 4 out here is being multiplied by everything inside the parentheses. So we can take 4 times x, giving us 4x, 4 times 3, giving us 12, and then that is actually our answer, because the 4x and the 12 are not like terms. We cannot add them. We cannot combine them. So that would be our simplified answer. That's the whole point of simplifying, is we just get it as simple, as basic as possible. Sometimes it's a solid number. Other times it's still an expression. All right. Now let's switch on over to IXL. We'll get a lot more practice. Hopefully this kind of helped you understand the reason why it works. But if not, no worries, maybe you will by the end after you see a few more examples. Sometimes it takes a little bit to click in. All right, we've switched on over to IXL now. Notice that it's assignment UQL, multiply using the distributive property with negative numbers. After you finish this video, if you feel like you need a little bit more help, please watch the video that IXL has, because sometimes just hearing it from a different point of view, hearing it come from a different voice can just make things click. So check out IXL's video if you need a little bit more help after this one. All right, let's look at our first problem here. We are being asked to simplify this expression. I'm going to rewrite it so we have room to work it, but I see 3 times the quantity of 1 plus 2x. So I see those parentheses. That's where my eyes go to. Can I simplify? Can I do what's inside the parentheses? Can I add 1 and 2x? No, we cannot, because they're not like terms. When you're combining things, that means adding and subtracting, they have to be the same. They have to be like terms. So 2x and 5x would be like terms, or 2x and negative 10x would be like terms, because they both have the exact same variable. But here, the 2 has a variable, the 1 doesn't, so they're not like terms. I cannot combine them. I cannot add them. That means the only way we can get rid of our parentheses is through the distributive property, because not only are those parentheses grouping the 1 and the 2x together, there's also this 3 on the outside being multiplied. So we can multiply, we can distribute that 3 to everything inside the parentheses. So we can take 3 times 1, which would be 3, bring down your plus sign. And then we can also take 3 times 2x. And when you're multiplying, you're allowed to multiply one thing with the variable, one without. The combining only refers to adding and subtracting. So 3 times 2 would give us 6x. And this right here would actually be our answer, because once again, we have no like terms. The 3 is a constant. There's no variable. The 6 is a variable term. We have a 6x. Because they're not the same, that is all we can do to simplify, and that would be your answer, and you would type it in just like that into IXL in order for it to be marked correct. All right, let's keep going. Try a few more here. All right, we have 2 times the quantity of 2 plus v. All right, I look inside my parentheses. Can I combine like terms? Can I add 2 and v? Nope, I cannot add them because 1 has a variable, 1 doesn't. So what does that mean we need to do? Distribute, 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 distribute that 2, pass that along to everything inside the parentheses. If we think about if we're at a party here, everybody can get a slice of pizza at the pizza party. Everybody can get a drink from the soda machine. Everybody's going to get one that comes to the party. Okay, 2 is being multiplied times 2, which would be 4. Bring down your plus sign. And then we are also distributing that 2 to the v. So 2 times v would just be 2v. And that would be our final answer. There's no more like terms. The 4 is a constant. The 2v has a variable. It is not. That would be it. All right, let's take it up a notch and try it when we have some positives and negatives. The process is the same. You just might need to be a little bit more careful of your signs. So our problem here is we have negative 5 times the quantity of 8 minus v, all in parentheses. If I look at my parentheses, I don't have any like terms. I cannot take 8 minus v. So the only thing I can do is distribute, because those parentheses also mean multiplication. That negative 5 is being multiplied by everything inside the parentheses. So we're going to take negative 5 and multiply that by 8. A negative times a positive is a negative, so we would have a negative 40. Then I'm going to bring down my subtraction sign. And now I'm going to multiply negative 5 times v. And negative 5 times v would just be a negative 5v. Is there anything we could do to make this a little bit cleaner, to simplify it a little bit more? In this case, there is. If we look right here in the center, we have minus a negative. That's not really proper format. So remember, when we have minus a negative, they cancel each other out and it becomes a plus. It becomes a positive. So another way of saying negative 40 plus 5v. Now are we done? Yeah, now we're done. We've simplified, we've done as much as possible, but we have to stop here because there's no equal sign, so we can't solve, and we have no like terms. The 40 does not have a variable, the 5 does, so because they're not the same, we cannot add them, and that would be our answer, and you would type it in just like that, negative 40 plus 5v, and you would get it right. Let's do 2 more examples together. All right, when you get higher into the SMART score, you may see some decimals, but the thing is, it's honestly not any different. You have to multiply decimals instead of whole numbers, but the process of using the distributive property is exactly the same. Let's change up our color pen here. We've been using red for a while. Let's try purple. So if we have negative 0 and 4/10, and that's multiplied by 3 minus v. Can we do what's inside the parentheses first? Nope, no like terms. The 3 does not have a variable. The v is 1. But the way we can simplify, the way we can get rid of those parentheses is distribute. We can distribute that negative 0 and 4/10. We can multiply that negative 0 and 4/10 by everything inside the parentheses. So if we have negative 0 and 4/10 times 3, we have negative and 1 and 2/10. Bring down your minus sign. Now we have negative 0 and 4/10 times v, so that would be negative 0 and 4/10 v. Oh, just like that last problem, I need to simplify my signs. I don't want to keep it as minus and negative. That cancels out and becomes a positive. So we're left with negative 1 and 2/10 plus 0 and 4/10 v as our final answer, because we cannot add them because they're not like terms. They both don't have a variable, so they can't be added. All right, let's do one more problem here. All right, let's simplify this expression. We have 3 times negative 5 plus 2j. Can we combine like terms on the inside of our parentheses? Nope. That means we need to distribute. So 3 times negative 5 would be a negative 15. Bring down your plus sign. 3 times 2j, 3 times 2 is 6, would be 6j. Anything else we can do? Nope. That would be it. And I know I said one more problem, but I changed my mind. There's one more type that you may see on an IXL. So this time I mean it. Let's do one more together. Okay, well, I'm not finding it, so I'm just going to change this problem up to show you another type you may see on IXL. Okay, so I know that this problem is written as such, but you might see some problems on IXL where it's written backwards. Okay, if you have any problems like this where what you're multiplying by is at the end, that's not super common, but it doesn't really mean anything different. It's not the best way of writing it, but every once in a while you'll see it that way. You may even see it surrounded by a second set of parentheses there. But because it's still right outside the parentheses, it's right next to it, it's meaning multiplication. It's being multiplied, and we would go through the exact same process. So we would take negative 3 times 4x, which would be negative 12x. Bring down your subtraction sign. Then negative 3 times 3 would be negative 9. And oh, we're getting lots of these problems with negatives. We have minus a negative. That cancels out and becomes a positive. So becomes negative 12x plus 9 as our final answer. All right, I hope this helped out a little bit. If not, like I said, please check out the video on IXL or send me an email. I'd be more than happy to help. But I think you guys can do it. Try it out, and good luck. Bye.